Okay, let's try some more sample problems. This time, let's go over some of the conceptual questions in the Winter 2009 exam as a sample exam available on Moodle. Okay, so question number one. The device represented here in this picture is exposed to the atmosphere. What can be said about the pressure of the gas in the box compared to the pressure of the outside atmosphere? Well, first thing to look at is see that there's mercury in that U-tube. See that to the left, that gas chamber is totally enclosed, so the atmosphere doesn't press upon it. Meanwhile, the top of this tube is open to the atmosphere. Notice that the outside atmosphere must be pushing down harder on the mercury than the gas in the box is. Therefore, that means that the pressure in the outside atmosphere must be greater than the pressure of the gas inside. That would make the second choice the correct choice. Number two, air is flowing from the left to the right in the horizontal tube shown here. A U-tube is connected to the horizontal tube and partially filled with mercury. How will the level of the mercury on the left side of the U-tube compare to the level of the mercury on the right side of the U-tube? Well, remember that by Bernoulli's discovery, fast-moving air has lower pressure than slow-moving air. At point 1, the air will be moving a lot faster than at point 2 because there is a smaller cross-sectional area for it to travel through. That means that at point 1, the air pressure will be less. The greater air pressure at 2 will therefore push down harder, which means that the mercury level will be higher on the left side of the U-tube. By the way, make sure you're actually checking that my answers are right. It's currently about 10 o'clock and I've been traveling all day, so who knows where my thinking process is. Okay, question 3. The two dams here are built to hold back equal amounts of water. Which dam experiences the greater force at the bottom? And of course, pressure is only related to depth when it comes to a stationary fluid. Therefore, the deeper dam will need to be stronger. It doesn't matter if the deeper dam is holding back if the shallower dam is holding back an entire ocean, and the deep dam just a few meters of water, the deeper dam is always going to need to be stronger at the bottom. 4, I like 4. 2 identical beakers are filled to the same height with water. Beaker B has a plastic sphere floating in it. Which beaker with all of its contents weighs more? Okay, so notice that with the ball floating in B, the water levels are the same in A and B. Okay, here we have to think of Archimedes' principle. Remember, Archimedes' principle is that the upward force upon an object, either fully or partially immersed in water, is equal to the weight of the fluid displaced by that object. So, in other words, the upward force on that ping pong ball, or whatever it is, in B, is going to be equal to the weight of the water that's in that lower half of where that ping pong ball is. So in other words, if that ping pong ball were replaced by its equal displacement value of water, it would fill that hole where B was. Bottom line, the correct answer is the weight of A should be equal to the weight of B. Okay, hope you got that one. So that's the third option in that one. You and your friend have just bought new tuning forks, each originally tuned to a frequency of 400 hertz. You accidentally drop yours, putting a big dent in it. When you and your friend both strike your tuning forks to make them ring, you now hear a beat of 3 hertz. The whole beat thing's kind of cool, I think. Which of the below statements is true? Well, the thing to remember here is that the beat frequency is equal to the absolute value of the difference between the frequencies. So in this particular case, we don't know if the dinged tuning fork went down to 397 or up to 403. Could have been either. So the correct answer is there's not enough information to know to what frequency your tuning fork has been tuned. Cool. Okay, number 6. You're late and you want to listen to KBVR at a certain frequency. However, due to spilling a milkshake upon the dashboard of your car can only pick up 101.5 megahertz. You decide to use the Doppler effect in order to pick up the radio station. Which scenario will allow you to pick up the radio station, assuming your car can drive fast enough? Well, so first question, are radio waves sound waves or light waves? And the correct answer, of course, is not sound, but rather light. And if we want to, that's right, folks, it's light, not sound. Radio waves are part of the electromagnetic spectrum. Matter of fact, radio waves are often on the order of centimeters or meters long. So, do we need to drive towards it or away from it to get to that higher frequency? Well, we want to drive toward the radio station. Question 7. What is the frequency of this traveling wave? Well, by looking at the wave, we can see that the wavelength, if I'm reading this right, is 10 meters. So we know that wavelength here is going to equal 10 meters. In order to get frequency, we're going to have to remember that the speed of a wave is equal to its wavelength times its frequency. Always make sure your units are correct, which they are in this case. That means frequency is going to be v divided by wavelength. The velocity, according to the problem, is 50 meters per second. The wavelength is 10 meters, so that means that the frequency must be 1 over seconds. Well, better stated as s to the minus 1. Which, of course, is defined as hertz. So the answer is 5 hertz. Okay, so I think I'm going to stop there as I'm worried I'm getting close to my limit here. Hope that helped a bit, and I'll be posting another set of answers pretty soon.